Solving inequalities is just like when we're solving equations. We still need to use the inverse operation. Let's review what inverse operations are. They are the opposite operation that will undo. So if I'm adding, I need to subtract. If I'm multiplying, I need to divide. If I'm subtracting, I need to add. And if I'm dividing, I need to multiply. So we need to view solving inequalities like an equation. So I'm going to rewrite our inequality statement on example 1, where we have m plus 2 is greater than 6. This means that any number plus 2 must be bigger than 6. All right, so if I rewrite this as an equation, m plus 2 equals 6. That means that m must equal 4, because if I use the inverse operation of addition and subtract 2 from 6, I'm going to get 4. So that means m equals 4. So m must be 4. So let's think about this for a minute. If I replace m with 4, 4 plus 2 is not bigger than 6. It's equal to 6. So when I solve it like a normal equation, I need to replace it at the end so then it makes sense at the end. So if I put this in and I undo and I have m is greater than 6 minus 2, that means that m must be bigger than 4. That means any value bigger than 4 is going to work for this solution. So if I pick a number bigger than 4, let's say 4.5, 4.5, so I'm going to go ahead and replace my variable, plus 2, that should be larger than 6. And if I do 4.5 plus 2, I end up getting 6.5, and that is bigger than 6. All right, I can also pick another number that is greater than 4. So let's say I pick 10. 10 is bigger than 4. So if I replace m with 10 now, 10 plus 2 is 12, and 12 is greater than 6. So the answer to this inequality statement, m plus 2 is greater than 6, the answer is m is greater than 4. So that means any number bigger than 4 is going to work. So if I pick a number bigger than 4, like 10, 4.5, all those numbers, that is going to work for that inequality statement. So we solve it like an equation, but then we need to think we've got infinite solutions because this is an inequality symbol. So we have many solutions to this example. All right, let's go on to example number 2. 8h is less than 40. So this means h times, or 8 times any number that we can replace with h must be less than 40 when we multiply those. So how do I figure out which numbers those would work? So again, if this is multiplication, I need to do division. So h less than 40 divided by 8. So h must be less than 5. So this means any number less than 5 will work. So I'm just going to go ahead and pick some whole numbers that are less than 5. I'm going to pick 0. 0 is less than 5. So if h is 0, 8 times 0 is less than 40. Well, that's 0, and 0 is less than 40, so that works. Okay, let's pick another whole number less than 5. Let's pick 2. 2 is less than 5, so I'm going to replace h with 2. 8 times 2 is 16, and 16 is less than 40. So any number less than 5 will work for this inequality statement when I replace it with h, okay? So this is definitely a little bit more thought process than solving equations, because again, I can have multiple answers. And again, I can graph these as well if I wanted to show the solution to this problem. And I, again, would put an open dot on 4 And remember, M is any big number bigger than 4. So that would be 5, 6. So we would go ahead and shade. So any of these numbers are going to work if I replace them and add 2. Okay, because 5 plus 2 is 7. That's bigger than 6. 6 plus 2 is 8. That's bigger than 6. All right, same thing here. If I want to graph this, okay, again, I'm going to put an open dot on 5. That means any number less than 5. So 4 works, 3 works, and so on. So all of these numbers are going to work, including my decimals. So 4.5, 4.7, 4.8, 4.9, 4.99. Any number less than 5 times 8 will make it less than 40. And that is a short lesson on how to solve inequalities.